In this video, I'll be talking about solving inequalities by adding or subtracting. What you'll find is that solving inequalities by adding and subtracting is the exact same as solving equations with adding and subtracting. So if I give you this equation, m minus 3 equals negative 24, you would solve it by adding 3 to both sides and getting m equals negative 21. What I notice when I look at a lot of your tests, the problems that you're missing, it's obvious to me that you're not plugging in your answers to see if you got it right. Once you get an answer, m equals negative 21, an easy way to check your answer is to plug in this value where the variable was. So I'm going to plug in negative 21 for m, and then we have that minus 3 equals negative 24. So I'm going to simplify this left side. It says negative 21 minus 3, and it's correct. So this is just the check. The answer is right here, but this is how I check if my answer is correct. So if I was taking a test and I had extra time, or if I was as I was going, I would just plug my answer in and see if it made sense. Sometimes just an estimate is good enough. Okay, so now I'm going to show you how that works for inequalities. So I'm going to write the same exact problem, except this time it's going to be greater than negative 24. You'll notice I solve it the exact same way. Plus 3 on both sides, ending up with m is greater than negative 21. So now in this case, to check my answer, I can choose some number that's greater than 21, negative 21. So I can choose negative 20 or 0 or a million or something. So I'm going to try negative 20 because it's pretty close. So negative 20 minus 3 is greater than negative 24. And I'll simplify this side. Negative 23 is greater than negative 24. Sometimes this looks a little interesting for people when we're dealing with negative numbers. Remember, negative 24 is over here, negative 23, 23 is here, and then whatever, this might be negative 20 or something. So this number, 24, is actually less than 23, right? So this is correct. So that's a check. So our answer was m is greater than negative 21. Notice it looks similar, except it just has the inequality symbol versus the equality symbol. I'm going to do a couple more examples here. Let's say I did p minus 9 is less than negative 9. So I'm going to add 9 to both sides. And that leaves p on the left side. The inequality symbol stays the same, goes the same direction. And negative 9 plus 9 is 0. You also will need to be graphing the solutions here. So the graph of that doesn't have to be fancy. I'll just put a 0 somewhere and maybe one other number or 2 other numbers just to get an idea of where everything is. And then it's going to be less than, so that's an open circle at the boundary, which is 0. And less than, so things like negative 1, negative 2, negative a million. And that would be the answer. Alright, now you can also do the addition style expressions. So if I had r plus 9 is greater than or equal to 4, as you might guess, you're going to subtract 9 from both sides. So you'll get r is greater than or equal to. Notice the symbol stays the same. And 4 minus 9 is negative 5. To graph that, again, doesn't have to be real fancy. Put a negative 5 somewhere. Negative 6 is over here. Negative 4 would be here. And we need greater than or equal to. So that means it's a filled in circle. And greater than, so like negative 4, 0, 100 would all work. This will also work, obviously, with fractions and decimals. So if you want to do something like h minus 9 is less than 1.3, you do it the exact same way. Add 9 to both sides. Always looking at the side that has the variable to figure out what to do, never the other side. Same direction, notice. 9 plus 1.3, that's 10.3, and graph it. It doesn't have to be fancy. I could put this at, I could say this is maybe 10, this might be 11, 12, 10.3 might be around here. 10.3. It's less than, so that is an open circle, and less than is this direction. Alright, let's try a fraction. Fractions shouldn't be any more difficult. You do it the exact same way. So if we had negative 3/4 is less than w minus 1/4. So same exact technique. If this is a whole number, if it's a fraction, doesn't matter. We're going to look at the side with the variable and do the opposite. So we're going to add 1/4, add 1/4. On this right side, we're going to get a w. On the left side, well, what we end up with really is negative 3 plus 1 over 4, right? So that's negative 2 over 4, which is negative 1/2. Remember this negative, it can go here. The negative 1/2 is the same as negative 1 over 2 or 1 over negative 2. This is probably the best way to think about it because then you see that one of the numbers is negative, one is positive. This is another way. This is not usually the way you see it with the negative on the bottom. So we have w is greater than negative 1/2. To graph that, we want negative 1/2 somewhere, so maybe we'll have a 0, negative 1, negative 1/2. And to graph it, we need an open circle at the boundary, and we need to be greater than, and that is up this direction. Alright, one more. We can also have compound inequalities. So if this said like negative 2 is less than or equal to x minus 7 is less than 10, to solve this one, just look at where the variable is, as usual. Now notice there's 3 parts. There's not 2 sides in this case. There's actually 3 parts. So look at the variable. We have x minus 7. The opposite of that would be adding 7. Now we're going to have to do it to every part, right? So plus 7 to the left, plus 7 to the middle, plus 7 to the right. So we end up with 5 over here, less than or equal to x, right here. Was less than 17. And the way you graph that is you're actually going to have 2 boundary points. You're going to have one at 5, one at 17. And other than that, it's pretty much the same. So x needs to be greater than or equal to 5, so that's a filled-in circle at 5. It also has to be less than 17, so that's an open circle at 17, and it's just everything in between. So everything that's shaded should work if you plug it in. So I'm just going to pick a random number in here, so something like 11. If I put 11 in here, it's true. 5 is less than or equal to 11, which is less than 17. So any number you pick in the shaded region should work, and if it doesn't, then you've made a mistake somewhere. And that's it for the video. Thanks for watching.